Okay, so in the last video, we evaluated the derivative of this guy using the chain rule. Now, just for fun, let's find his derivative using the quotient rule instead. Perfect way to do it. Oh. Perfectly fine way to do this. Here we go. Okay, so h prime of x, we're thinking quotient rule now, and I'm leaving him in his original form. Quotient rule says, oh, I want the derivative of the top, derivative of 1 is just 0, times, leave the bottom alone, minus, leave the top alone, times the derivative of the bottom. Oh, look, I'm going to have to use chain rule again here. So over on the side, I'm going to have to think about how to do 3x squared plus 1 squared and take his derivative. That's still a function inside a function. So this derivative would be, take the derivative of the outside. Derivative of junk squared is twice junk to the first power. The 2 comes down, becomes a 1. The inside gets left alone, times the derivative of the inside. So that is just the derivative of the bottom. So that's 2 times 3x squared plus 1 times 6x all over the bottom squared. So I want 3x squared plus 1 squared and then squared again. Okay, now let's clean that up a little bit. 0 times anything is just 0. So I'll get here -1 times 2 times -6. So I'll get -12x 3x squared plus 1 to the first power divided by 3x squared plus 1 to the fourth power, because I have squared. Oh, I can cancel out one of those common factors, and I get -12x over 3x squared plus 1 cubed. And look, that's the same answer I got using just chain rule. Okay. So the point that I'm making right now is there are a lot of times when you might think, oh, I want to use quotient rule, when I would suggest rewriting your function using negative exponents instead and use chain rule instead. Doesn't always help, but a lot of times it will. And it's good to know how to do it both ways so that you can check your answer. We're going to do a lot of similar examples. It's a good place to stop that one.